Hello everyone, today we discuss sorting and design problem, LeetCode algorithm problem 729, my calendar 1. There are another two follow-up problems, my calendar 2 and my calendar 3. We will discuss them later. Okay, firstly, let's see the description of this problem. You are implementing a program to use as your calendar. We can add a new event if adding the event will not cause a double booking. A double booking happens when two events have some non-empty intersection. The event can be represented as a pair of integers start and end that represents a booking on the half-open interval start end. The range of real numbers x such that start is smaller or equal to x and x is smaller than end. And then we need to implement the calendar class. Okay, today we use Python to solve this problem. For this sorting and design problems, we always use sorted list in Python, and we need to import it. So we need to use this from sorted containers to import sorted list. So if we create a new sorted list and add tuples or numbers into it, the sorted list can help us to maintain its sorted order. And the time complexity to sort the list will be O(n) log n. Okay, firstly, we write the initialization function. So we set self.calendar to be a sorted list. For example, we have a sorted list here because in this design problem we have two elements, start and end time, so we need to insert the two number tuples into our sorted list. In this case, the sorted list will sort the list by the first element at the first. So let's see here. These three tuples are sorted by the first element because 10 is the smallest, and 20 is larger than 10, and 40 is larger than 20. And if the first element is the same, so for example, if we have 10, 20 and another tuple 10, 15. So for these two tuples, they have the same first element 10. So in this case, the sorted list will compare the second element. So we need to compare 20 and 15. So 15 is smaller than 20. So in this case, the sorted list will maintain order as 10, 15, and then 10, 20. However, in this scenario for design problem, we will not have oversighting intersection, which is a double booking here. So here we can say the 10, 15 and 10, 20 will have overlapping intersection 15 and 20. So here we can only maintain one. So we cannot add the new event 10, 15 here. So we can say if we want to add a new event, for example, this 35, 38, we need to find the position to insert it by using the binary search for the first element. So we need to find use the binary search to to find how we can insert 35 in the first element made list. So we need to find the 10, 20, 40, and which one is smaller than 35 and which one larger than 40, so we can find the position. Here we can see by using the binary search we can find 35 is larger than 20 and smaller than 40. Here the bisect right is the Python built-in function for us to use to implement binary search. So by yourself.calendar, here is our sorted list dot binary sect right, and we input start and here then we can use the start as the target number, and we use binary search for the first elements in the list, so we can know the index of the list that this new start and can be inserted into the sorted list. And then the binary search here have a time complexity O log n. And you can see right here, so by using the bisect right, we will know the rightmost position that we can put in the tuple. Here if a lot of tuples have the same first element, so if we don't need to consider the overlapping case in the sorted list, so if we have a lot of tuples have the same first element, like 10, 15, 10, 16, and 10, 20. So if we want to add a new event like 10, 18, then the bisect right will find the rightmost position that we can insert it into the sorted list, which will be the position here. So the index will be index 0, index 1. So this function for the new event 1018 to insert into this sorted list, the return value index will be 2 here. Okay, because we don't allow an overlapping, so we just delete them and consider a new event, the previous one, 35, 38. So after we use the binary search to find the position here, so for the sorted list, this one, and if we want to add the new tuple 35, 38 into it, by using the binary search function, we will find the return value as 2, which is the index here. So we need to find out whether the new index will have any overlapping space for the adjacent events. So here we need to consider whether the start time of the new event will have overlap with the previous event. So here we can say the index is the new event, and the index -1 here will indicate to the previous event before the new event. So here is this event 2030, and then the one here indicates the end time, so which will be 30 here of the previous event. So we need to compare 30 the end time of the previous event, and compare it with the start time of the new event 35. Here we can see the end time of the previous event 30 is smaller than the start time 35 here. So in this case, we will not have an overlap. And then we also need to consider whether the end time of the new event will be smaller than the start time of the next event here. So we need to compare the end time 38 here with the start time 40 in the next event. So for the next event, we will have the self-calendar index. Here the index is the position that we want to add the new event in, but actually currently in the self.calendar index means the current index 2 tuple here. So here the self.calendar 20 means the start time of this tuple 40. So we need to compare the 40 with the end time of the new event that 38 that we want to add into the list. So here 38 is smaller than 40, so there will not have an overlap. That's why the self.calendar index 0 needs to be smaller than the end time of the new event. Here we have index needs to be larger than 0 because we need to consider the corner case here. So we need to ensure that the index -1 needs to be larger or equal to 0. So which means we have index larger than 0. And here similar, we need to make sure that the index is smaller than the length of the list. So we have index for this one to be valid. So here we have index is smaller than the sorted list length. So here we can say if the start time of the new event is smaller than the end time of the previous event, or the here is the end time of the new event is larger than the start time of the next event, which will cause an overlap. So we need to return false. Otherwise, we can just add the new event 38 into the sorted list. Here we can see we have 35, 38. And the new tuple will become the new self.calendar index 2. And then the previous index 2 tuple 40, 50 will become index 3. And then the add function will have a time complexity O n log n. By this way, we can solve this problem, and the time complexity will be in the adding time complexity O(n) log n. And our binary search has a time complexity O log n, which is smaller than the adding time complexity. So the time complexity will be the largest time complexity of the functions. So which will be O(n) log n, and then the space complexity is O(n) because we need to maintain the sorted list, which will have a space complexity as O(n). Okay, we will finish here today, and later we will discuss my calendar 2 and my calendar 3. See you then. Bye bye.